Okay, this is I'm just adding for the sake of some basic small interaction. uh, I'll just check if I'm getting audio or not. Yeah, looks like it working. Okay, so I was just reading this module which is about selecting data for modeling. So your first machine learning model, selecting data for modeling. Your data set has too many variables to wrap your head around or even to print out nicely. You can pare down this overwhelming amount of data to something that you can understand. We will start picking up few variables using our intuitions. Later courses will show how statistically techniques to automatically prioritize variables. To choose variables, we'll need to see a list of columns in the dataset. So this is done with the columns property of the data from the bottom below. Okay, so basically here we are just selecting the here we are just trying to see the columns in the data set. So this is importing pandas, selecting the file, then loading the file in the data by reading it and then printing the column. So melbourne data dot column is equals to whatever the columns here. Yeah, what's they are saying that the melbourne data has some missing value, some houses for which some variables were not recorded. We will learn to handle missing values in later tutorial. Your IOWA data doesn't have missing values. What is your what is this? Okay, so I think it's a state in US. Data doesn't have any missing values. Uh, columns you use. So we will take the simplest option for now and drop houses from your data and drop houses from. Okay, so if the data is not available, we'll don't worry about this much for now though. Okay, so melbourne drop now drops missing value, think of it not available. So melbourne data drop now axis 0. So basically axis 0, I think it's gonna be rows they are dropping. There are many ways instead ways to select a subset of your data. The panda course The Panda course cover in these more depth, but we will focus on two approach for now. Dot notations, which we use to select the prediction target, selecting with a column list, which we use to select the feature. There are many ways to select the subset of your data. The Panda course covers these in more depth, but we will focus on two approaches for now. There are many ways to select a subset. Okay, there are many ways to select a subset of your data. The Panda covers these in more depth, but now we will focus. There are many ways to select a subset of your data. The Panda course covers these in more depth, but we will focus on two approaches for now. Where one is the dot notation, which we use to select the prediction target, and the second is a column list, which we use to select the features. Okay, so basically, if we have to select the product prediction target, and if we have to select a column, then it's called the feature. Selecting the prediction target, which is the first method, you can pull out a variable with dot notation. This sing this single column is stored in a series, which is broadly like a data frame with only single value column. Okay, we will use dot notation to select the column we want to predict, which is called a prediction target. By convention, the prediction target is y-axis. So the code we will need to save the house price in the melbourne data is this. Choosing features, the column that are input into our model, the columns that are input in our models and later used to make predictions are called features. In our case, this would be the columns used to determine the home prices. Sometimes you will use all columns target as feature except the target as features. Other times you will be better off with fewer features. For now, we will build a model only a few features. Later on, we'll see how to iterate and compare models built with the different features. We select multiple features by providing a list of column names inside brackets. Each item in that list should be a string with quotas. So melbourne features is basically rooms, bathroom, land size, latitude. Okay, by convention the data is called x. By convention, the data is called, so features are called X, okay, and then Y is called the price prediction type. Basically, what we have, selecting the prediction, what we have to, what our basically model has to do is to predict the target, right? So basically, that has been taken in the, let's quickly review the data we will be using to predict house prices using the describe method. So now whatever got selected in these features, we are describing and selecting that here. X dot head is gonna select the first five. Visually checking your data, these commands is an important part of your data scientist jobs. You will frequently find surprises in the data that deserves further inspection. So okay, building your model, you will use scikit-learn library to create your model. When going with the library is written as sklearn. As you will see in the sample code, scikit-learn is easily the most popular library for modeling the types of data typically stored in the data frames. The type of, okay, so basically what are the data, if we are making a model which is storing its, which is more of a representation in the data frame, then we will be using scikit-learn. Is easily to the most popular library for modeling the types of the data typically stored in the data frame. The steps to building and using the models are define what types of model it will be, okay, a decision tree or some other type of models. Other some other parameters of the models are specified too. Capture pattern from provided data, this is the heart of modeling. Capture patterns from provided data, this is the heart of the modeling. Just what it sound, and then predict, and there is a evaluate determine how I get together. Here's an example of defining a decision tree model with scikit-learn and fitting it with the features and target variables. Okay, uh, okay, so jitne bhi, I guess all the models that we are gonna see, they are already implemented in some, in these libraries looks like, and we just have to know, is it like we just have to know all the possible uh, models and where to apply, that's the job. So from sklearn.tree import decision tree regression, define model, specify a number of random state to ensure same results each run. So Melbourne model decision tree regressor, okay, random state is equals to 1. I'm not sure what does that mean. Fit model, okay, fit model Melbourne model dot fit is equals to x comma y. Decision tree regression, okay, random state to 1. Machine learning models allow some randomness in model training. Specify a number for a random state, ensures you get the same results in each run. This is considered a good practice. You use any number and model quality won't depend meaningfully on exactly what you choose. We now have fitted model that we can use to make the prediction. In practice, you will learn to make predictions for new houses coming on the market rather than the houses we already have prices for, but we will make predictions for the first few rows for the training data to see if the prediction works. Making prediction for the following five, okay, x dot head prediction, model Melbourne model dot predict. So so we have defined Melbourne model as the decision tree of this, and then Melbourne model fit x comma y. I don't know what by fitting we are doing, uh what by fitting we are doing. So Melbourne model dot predict dot x dot head, so basically making prediction for the following. So where is the prediction is, okay, this is the prediction, but what does this mean? Try yourself. Okay, I did not understand few things, so let me just take a screenshot and go to our friend, wait, go to our friend Gemini. Hey Gemini, I am trying to learn machine learning from one of the Kaggle learning module, and I came across the learning model chapter where I found the following notes attached in the image. Can you explain me few things? Does in machine learning we have all the models, or I can say the type of models, are already built, and we just have to know which model is gonna be more useful and kind of use that from an existing library. For example, here uh, decision tree regressor from the sklearn. Let's see. What's it? Okay, it's great that you are diving into machine learning. That Kaggle course, the Melbourne housing example, is a classic starting point. To answer yes and no, here is a breakdown how built-in model works in the industry. The off-the-shelf reality for the 90% of standard tasks: predicting prices, classifying email, identifying churn. I don't know what that is. We do use pre-built architecture from libraries like scikit-learn, XGBoost, or PyTorch. You don't need to write the mathematical logic for how a decision tree splits data from scratch. Experts have already written highly optimized code for this. Your job as a machine learning is often to select the right tool, knowing when to use decision tree versus a linear regression, prepare the data, cleaning the rooms, and land size the data so that the model can understand it. Turn the model, adjust settings, call the hyperparameter to make it more accurate. Why are not models already built? While the algorithm, the math is built in model, the model is not smart until you feed it your specific data. The architecture, the decision tree regressor is simply like an empty filling cabinet. It has a structure but not information. When you run the Melbourne model filling, you are filling that cabinet with pattern from Melbourne housing data. Mm, so is that fit function specific to the decision tree regressor model or something from the sklearn itself? Great question. This actually is one of the reasons scikit-learn is so popular. The fit function is not specific to the decision tree. It is a universal standard across almost the entire sklearn. The estimator standard, the sklearn, every model, whether it's a decision tree, a linear regression, or a support vector machine, is called an estimator. Okay, every model is called an estimator. They all follow the exact same blueprint. .fit.x, this is learning phase where you telling the model look at the features x and their corresponding targets y and find the pattern. Predict x, this is the application phase where you are telling the models, now that you have learned, look at these features x and tell me what you think the target y should be. Okay. mm, is that what they are doing? Okay, press okay, and x dot head. So basically x dot head is about predicting the first 5 value from from the from the model trained on the data. Exactly, you need the logic, but there is one subtle and very important distinction to make about which data the model is looking at in screenshot of what is happening in a particular. When you run that line, you are asking the model to take the first 5 rows of the feed of your feature X, pass them through the pattern. It's just learned during the fit step. Output its output its best guess for those house. Okay. Hmm. Oh, it price है. Hmm. Okay, sounds good. Let's start the exercise. Hmm. Let's start the exercise. Okay. So far, you have loaded your data and reviewed it with the following code. Run this cell to set up your coding environment where the previous step left off. Okay. Import path वगैरह 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 वगैरह. Okay. So set up the code checking from learn tools.code import. Okay. This is kind of a predefined. Okay. Exercise 1. Specify prediction targets. Select the target variable which correspond to the sale price. Save this to a new variable called y. You will need to print a list of all the columns to find the name of the columns you need. You need to print a list of all the columns to find the name of the columns that you need. Okay, print the list of columns. Okay, so basically to print oh yeah, what happened? Is it running? Setup complete. Okay, now what I have to do is I have home data, home data, home data. To print, what I have to do, uh, to print, क्या बताया था column, no. So to print I have to just was it a head? No, head for the first five. uh, Feature, no, not feature. um, Not feature. Let me just check what they did used. What they did use that for columns. I was knowing it. So dot coulmns. Let me just run it. Okay, perfect. Now y is equals to, they want me to select prediction target. So y is gonna be my, how they are selecting. uh, hmm. Okay, now they want to drop all the values. That's okay, but now they want me to select the price. So, and prediction target, they said that I have to correspond the sales price. uh, oh, let me just search control F sales. But either sales, where is the sales here? Okay, sale price is here. Okay, sale price is here. Okay, y is equals to home data dot sale price. Let's run. Correct. Okay, the line below hit. Okay, I do not need the hint. Now we need to create the x. Now you will need to create a data frame to predict. uh, but they have, we should have also dropped few of the things, right? Feature name. So to select the feature, we uses Melbourne feature is equals to these. I'll just gonna copy this thing. Feature name. Feature name. Okay, now you would predictions, you want only some column, or you will create a list. You just, you will just use the following. Okay, feature name, I don't know. Let's say considered features for this specific thing. I will be pasting that here. uh, and they need okay, lot area, they need years built, they need first year FLS, whatever it is, then second floor surface, full bath, then they need, I don't know what is this, but something. Why? And then okay, now select the, select data, और इसको कैसे select करता था यार, इसको describe. Okay, x is equals to Melbourne data with these features set. X is equals to MEL, yo Melbourne data. Okay, I will name it housing underscore data dot with these considered features, and if I run it, there is wrong because I used wrong notation and it should not be having this thing. Okay, with this considered feature, now housing data, select data corresponding to a feature in that feature name. So basically, is that something I have to use from the existing house data? Is that something I have to, okay, is not defined home data. Okay, so in that we have loaded X from the home data, these all features. Reviewing before building, or take a quick look at X and Y. So review the data, print a description or statistics from X. Print in the sense like I should just describe it, right? X dot describe and X dot head. Now, okay, so basically describe is described, and I don't know what's the head. If I just do this, ये तो हो गया, देन ये प्रिंट करने के बाद वो क्यों हट जा रहा है पीछे वाला? Okay, create a decision tree regressor and save it Iowa models. Ensure that you have done the relevant import from sklearn to run the command. Okay, from sklearn, इसको कैसे करते हैं यार, इतना तो मेरे को याद भी नहीं रह रहा. So basically building from sklearn.tree, from sklearn.tree import DCISS decision tree regressor. Iowa model is equals to I have to fit the models, right? But before that there was a step where I was using the random stain. So Iowa model is equals to Iowa model is equals to which? Home data decision tree. Okay, so whatever the model is, I have to use the decision tree regressor random state is equals to 1. Random state is equals to 1. Fit the model Melbourne model dot fit IOWA model dot fit, and fit पे I have to fit the x comma y. If I run this, so many errors. Specify the model. That's what I did, right? Specify the model. That's what I did. If I have not copied it correctly, that could be an issue. So let me just, okay, yeah, that name was not correct. Now more predictions. Make predictions with the model predict command using x as the data. Prediction is equals to IOWA underscore model dot predict how to fit we already did. So have fun on how many we have to do it. So I guess I have to define that on how many predictions. So let me I do X. Okay, so for everything I did, and think about your results. Use head method to compare top 3 predictions to the actual values of Y for the same house. Okay, you can write use head to compare. Okay, so I can write actual values of x x x dot head, and I guess then prediction. Hmm. Predictions. Okay, but how can I compare? How can I write a comparison? Let me write both the print here and here, and then will I be able to compete? Okay, no, the actual values are going that I have to specify is would be something from, see, the prediction has been made on the top 5, so technically I have to print here house data dot sales price, which is Y. So technically what I have to print here is Y, and I don't know if it's the right or not, because none of the values are matching. This match, but this is, oh, okay, so this is the starting one, 208500, that is matching with this one, and 185110, this is matching with this one, 223, this is matching with this one. So everything is matching. How could that be? Everything is, this is also matching. But overall, I think what was the takeaway from this specific session was how, what actually, so basically I have to first figure it out how can I understand the implementation of the decision tree regressor in the sklearn and the math behind it, what the model algorithm is actually doing. Is there any official documentation about this model? How this come? Okay, so basically decision tree regressor. They have decision tree regressor. Okay, so they have a decision tree 101. Supervised learning. Decision tree are a non parametric supervised learning method used for classifications and regression. The goal is to create a model that predicts the value of a target variables by learning simple decision rules inferred from the data features. A tree can be seen as a piecewise constant. Okay, for instance, in the example below, decision tree learns from the data to approximate a sine curve with a set of its if then else rules. The deeper the tree, the more complex the decision rules, the fitter the models. Okay, simple to one. See the algorithm for more information. So decision tree algorithm. Hmm. यहाँ पे actual मैच शुरू हुआ है भाई. So this is the algorithm which is being used in the C4.5 is a successor to ID3 and remove the restriction that features must be categorically dynamically defining a discrete attributions that permits the continuous attribute okay, converts okay. Cart classification regression is a simple is a similar to C4.5 but it differs that it supports numerical target variables cart with restrictions okay mathematical function. So basically classification regression and then decision tree. Okay, good. Now I think I have to study that. So I have to make a note of the thing which I have to learn. Okay. Huh. I guess I can finish one more thing. So model validation start tutorials. Okay. You have built, but how good is it? In this lesson, you will learn to use the model validation to measure the quality of the models. Measuring the model quality is the key to iterating, improving your model. What is the model validations you want to evaluate? Almost every model you ever built. In most, though not all application, the relevant measures of model quality is predictive accuracy. In other words, will the model predictions be close as to what actually happens? Many people make a huge mistake when measuring predictive accuracy. They make predictions they make predictions with the training data and compare those predictions to the target values in the training data. They make predictions with their training data and compare those predictions to the target value in the training data. You will see the problem with this approach and how to solve in a moment, but let me think about how we would do it first. You would first need to summarize the model quality into an understandable way. If you compare predictive and actual home values for 10,000 for 10,000 houses, you will likely to find mix of good and bad predictions. Though through a list of 10,000 predicted and actual values would be pointless. Looking at those list of 10,000 predicted value will be possible. We need to summarize into a single metric. Okay. There are many metrics for summarizing model quality, but we will start with one of the model called mean absolute error. Okay. Let's break down this metric starting with the last word error. The prediction error the prediction error of each house is error is equals to actual minus predicted. So if a house cost 15,000 and you predicted it would cost 10,000, in the error error is 50,000 for sure. With the MAE metric, we take the absolute error values of each error. This converts each error into a positive numbers. We then take the average of those absolute errors. This is our measure of model quality. In plain English, it can be said as an average. Our predictions are of about X. To calculate MEA, we first need a model. This is built in model this is built that is built in a hidden cell below, which you can review clicking the code button. Okay, so there is a model which is hidden. So basically they imported pandas, there is a file and they read the file, then they drop the rows with the missing price values, then they define the y as the price. From features that they included is this: the filtered data is this, the xml filtered Melbourne data is equals to Melbourne. Okay, they imported the decision tree, then they defined the decision tree regressor, and then fitted the models. Okay, once we have a models, here is how we calculate the mean absolute error. So from predicted home prices is equals to predict x, so all the values of x. Now absolute error, mean absolute error is equals to y, and predicted home prices, this gives this one. The problem with the in-shape score, what is that in-shape scores? The measure we just computed can be called in-sample score. We used a single sample of houses for both building the model and evaluating. Here is why this is bad. Imagine that in large real estate market, door color is unrelated to home prices. However, in the sample data you used to build the model, all homes with green doors were very expensive. The model job is to find the pattern that predict home prices, so it will see this pattern. The model's job is to find the pattern that predicts home prices, so it will see these patterns and it will always predict highest prices for homes with green colors. Since this pattern was derived from the training data, the model will appear accurate in the training data. But if the patterns does not hold when the model see the new data, the model would be very inaccurate when used in the predict practice. Since model practice of all value since model practical value come from making prediction of on a new data, we measure performance on data that wasn't used to build. We measure the performance on data that wasn't used to build the models. The most straightforward way to do this is to exclude some data from the model building process and then use to test the other model accuracy data that hasn't been seen. With this data is called validation. This is called the validation data. Okay, so there is another term called validation data. Coding it. The scikit-learn library has a function called train test split. To break up the data into two pieces, we will use some of that data as training to fit the model. We will use the other data as a validation to calculate the mean absolute error. Okay, that we have got already. Okay, this we got already. So basically from scikit model selection, and from where we imported, okay, from the tree we imported the decision tree regression. uh, Train test split, there is a function train test split the data into training and validations for both the features and target. The split is based on a random number generated, supplying a generic value to the random state argument guarantees we get the same split every time we run the script. Train x to validation x, train y validation y. So train split between x and y, random state 0, define model Melbourne state decision tree. We fit the model train x and train y, train x and train y, get the predicted value as the Melbourne data or predict value x. Wow, so we got this. On a single we got this. You Wow, you mean absolute error for in sample data was $500 out of okay, how they are coming up with this thing. You mean absolute error for in sample data was $500 out of sample it is more than $2,500. Okay, this is the difference between a model that is almost exactly right and one that is unusable for the practical purpose. As a point a reference, the average home value in the validation data is 1.1 $1 million, so the error in the new data is about the quarter of the average home value. There are some many ways to improve this model. You are experimenting to find the better features on a different type of models. Your turn. Okay. uh, but how? Okay, this they use the mean apps. Okay, got it. So now here we uh, kind of calculating the mean absolute error, which is basically so before our mean absolute error, which was coming, mean absolute error was coming as 500 when using everything, the model when trained on all the followings, and now it is coming 25. So basically, obviously there is a jhole. Now let's do. Okay, this is a machine course your reference. Okay, recap. I need to run this code as you have previously used to load data. This home IO model decision reprint IO model predict learn. Okay, setup complete. Come on, show me the setup complete together. Okay, now split the data. Use the trained import from. Okay, I know. Uh, from sklearn dot. Was it train or split? क्या याद भी नहीं रहता. Was it a train metrics? Okay, no. Model selection. Okay, from. Okay, from model selection I'm gonna import train underscore split underscore train test split train test split. Now I need to find train x train y using this train test split x comma y, oh, chotu y, from the model that I have before. On the models, random state 0, random state 0 आ गया, and this is gonna split it. But what I am missing, am I not defining? Okay, function, give it an argument, random state. Okay, random state 1, correct. So that check the function that was verifying the state random state. I still don't understand what is the use of the random state. Okay, let me first oh my god. Hmm. All right. Okay, okay. So ये तो मुझे समझ में आ गया, random state I have to use it, but now specify and fit the model for fitting. Oh, so basically I have to specify this. So I will write it again, specifying an Iowa model is equals to, let me write a DCISS decision. You imported this in your last exercise and that code has been copied to the setup above, so you need to, so no need to import it again. Okay, decision tree regressor I have imported. Iowa underscore model dot fit. Fit, I have to fit train x comma train y, because that's what we are using, train x comma train y. And we did oh, what decision tree regressor says or, what is this spelling, man? Regressor, decision tree regressor. Ensure that the random state, ensure that you created the model with, okay, so random state equals to 1. Okay, make the predictions with the validation. So val prediction is, I know, mean, I have to use it here, mean, absolute mean thing, absolute mean, absolute mean, where I will be using the value y. Val x with okay, so I have to first define to predict val. Based on this value, prediction is gonna be that model dot predict on value x. Now I got that. So this is technically okay. This is technically, I have to then do the val prediction, which is gonna be on I I wait Iowa model dot predict on val underscore x. Once it predicted, I need to use this to print the mean value of this. Oh, what's wrong? Print mean value absolute error, mean absolute error. What is the ask? Make predictions and with validation data. Okay, okay, I think I have to use it, not here. This got corrected. Now print the top few validation and the print the top few validation prediction. Print the top few actual prices from the validation. So is that gonna be like this? Mean value this is going to be the actual few validation predictions. print the top few actual prices data. That is going to be uh, that is going to be val y. Okay, that is going to be uh, what I think, val underscore y dot head. And can I do this here with that's head head? I don't think so, but how can I be selecting? Okay, mean absolute is not defined. भाई मीन एब्सोल्यूट एरर तुमने डिफाइन नहीं किया है. मीन एब्सोल्यूट एरर वो यहाँ पे कर रहे हैं बेसिकली. देन व्हाई दे आर okay. So they are saying that now, okay, that is gonna be predictions dot head, and this is gonna be well. इसमें तो क्या ही हेड होगा, ये तो पूरा प्रेडिक्शन ही है ना. Okay, this is this good? पता नहीं. What do you notice that is a different from what is shown in the sample predictions which are printed after the top code in the cell phase? Do you remember any validation prediction if from in sample training? How can I understand this thing? Top few validation predictions, so they predicted this thing. Okay, so basically what at the end I need to know mean absolute error when used with uh, val y comma prediction. It's value prediction. एक तो इस the bad thing is that this ID doesn't have this one. Okay. I mean, I learned this was quite progressing. So I guess tomorrow I'll then have to go through it once again because I learned that all the models are present already and I just need to in few cases split the data so that I can train on half of the data set and train on other half of the data sets, and that randomness of the data split can be controlled with the random state, and the random state value we are using in the decision tree as well and in the when we are splitting it as well. So yeah, that was the learnings from today. Not now, but so our time is up, but we'll go to learn and what we were learning. So three more things we have to finish. I guess tomorrow maybe two of them will be completed. Was a good one. I understand few things, and let me just stop the stream now so that we can connect tomorrow.